Good morning, students. Last lecture I have discussed the surface tension, that is definition of surface tension, tangential force per unit length acting on imaginary line drawn on the free surface of the liquid is called as surface tension. Now we discuss the surface tension on the basis of molecular phenomena. So consider this vessel containing liquid and there are four molecules. Consider the molecule A, that is, this is called as sphere of influence. Molecule A is completely inside the liquid and it is attracted equally by all the liquid molecule, and hence the resultant cohesive force acting on the molecule A will be 0. So this is the molecule A and the sphere of influence of molecule A is completely inside the liquid. Then this molecule A is attracted equally by all these liquid molecules, and hence the resultant downward force or resultant cohesive force acting on this molecule will be 0. Now consider the molecule B. It is just above the liquid surface. This is the molecule B. It is just above the liquid surface. Then its sphere of influence is partially outside the liquid and maximum sphere of influence it is inside the liquid. So for molecule B, maximum sphere of influence lies inside the liquid and minimum sphere of influence lies outside the liquid. So the lower half of sphere of influence contains large number of liquid molecules, and this molecule B, it will be attracted by the cohesive force between the liquid molecule, because we know that cohesive force, that is force of attraction between molecules of same type, is called as cohesive force. So molecule B, it is acted upon by cohesive force. Also it will be attracted by adhesive force. Adhesive force means force of attraction between the air molecule and this liquid one. But there are few air molecules, and that is why the resultant downward force acting on the molecule B, it will be maximum. Now consider the molecule C. It is on the liquid surface. Molecule C, it is on the liquid surface. Its half sphere of influence is outside the liquid and half sphere of influence is inside the liquid. Again, for the molecule C, the resultant downward force, it will be maximum. Then consider the molecule D. It is outside the liquid surface. Maximum sphere of influence of molecule D is inside the air and minimum sphere of influence of the molecule D, it is inside the liquid. So that means adhesive force, that is force of attraction between air molecule and this liquid molecule, that is adhesive force, it is maximum, and cohesive force For molecule D, it is minimum. So, the molecules which are lying on this liquid surface, say molecule B, molecule C or molecule D. So, the molecules which are lying on this liquid surface, they behave like a stretched membrane. That is, this portion is called as surface film and it acts as a stretched membrane, and it acts like a stretched membrane, like elastic rubber. There is, if we apply or if we stretch the rubber on both the sides, the force is called as tension. So, in this case, in case of liquid film, there is tension in the liquid film. It is called as surface tension. So, listen here once again. We are going to discuss the phenomena of surface tension on the basis of molecular phenomena. We consider the liquid in the vessel, and we are considering the four molecules, namely molecule A, molecule B, molecule C and molecule D. Molecule A, it is completely inside the liquid, hence resultant cohesive force acting on the molecule A, it will be 0. Molecule B, it is on the liquid surface, that is, in this case, resultant force, cohesive force is maximum, because number of molecules, air molecules in the upper half is less than number of water molecules in the lower half. Now consider the molecule C. Its maximum sphere of influence is inside the liquid and half sphere of influence is outside the liquid. Again, for the molecule C, resultant downward force is maximum. Consider the molecule D. Outside the liquid surface, its maximum sphere of influence is inside the air and minimum sphere of influence is inside the liquid. So, for molecule D also, here the resultant force is small because adhesive force is greater than this cohesive force. Then the molecules which are coming in this surface field, say molecule B, molecule C or molecule D, they will act like a stretched membrane. Surface film of the liquid acts like a stretched membrane, like to that of the elastic rubber. If rubber is stretched, then it gets elongated and stretching force is called as tension. Similarly, in case of liquid surface or liquid film, the tension is called as surface tension. So that ends the article, the surface tension on the basis of molecular phenomena.